Phil Switzer here. So we're going to do ionic compounds. What are they? How to write their name? How to write the formula. Once again, make sure you got your periodic table printed in beside you in a textbook. We're in chapter 2, page 44. Let me share my screen and we'll get underway. This will just take a moment. Come on, computer. There we go. Okay, so you should be seeing the notes that we're going to do together. Again, make sure you got some notes. Have your periodic table handy. And this is chapter 2, page 44. We're working out of. There's going to be some practice problems you're going to try afterwards. And then you're going to do an assignment that's in Moodle. Okay, let's get underway. Link for both the periodic table and the chapter 2 textbook is in the video information, the comment, the description of the video. Okay, let's get underway. First of all, what is an ionic compound? Let's take some notes with me here. Ionic compound, you can see some examples right here. They form beautiful crystals. They always form solids. An ionic compound is, on your periodic table, any of these metals can literally combine with any of these nonmetals, including stuff like carbon. If carbon had a charge, it'd be -4. In other words, it wants 4 electrons. Same with silicon, and if boron had a charge, they just don't form ions, but they do want to take, in this case, 5 electrons, carbon 4, nitrogen 3, oxygen wants to take 2, fluorine wants to take 1. You get the point that these guys give electrons and these guys take, and they can go together just like nice little Lego pieces. So it is indeed a metal, bonded, and it's a special type of bond to a non-metal. Okay, let's talk about that bond. What happens is the electron is actually transferred from the metal. So it's a transfer of electron, one, or it could be many, right? So we'll just put it like that, and it's from here to here. These are the givers. They give their little negative electrons away. It's called an ionic bond. This gives you an image in your mind of what an ionic bond forms. Nice crystal solids. For example, sodium, +1, and chlorine, good old table salt, right? So you take sodium, and it's got a charge of +1. Combine it with chlorine. It's got a charge of -1. This is going to nicely fit together, nicely balance out that charge. 1 sodium atom, 1 chloride atom, and it becomes an ion, right? When that sodium transfers, gives its electron to the chlorine. Once it gives its electron to the chlorine becomes an ion. So you got a sodium ion, chloride ion linked together, form a nice solid salt. This can dissolve in water and then give you back those ions that we're talking about. They're still atoms. They're atoms that have transferred electrons. In this case, the sodium gave its electron away to the chlorine, and the chlorine gladly took it, being a nonmetal. So that is what ionic compounds are. Let's figure out how to write the formula and their name. We're going to look at some examples here. Lithium combined with chlorine, calcium combined with bromine, and iron 3, the one with a +3, going to combine with nitrogen. But yeah, let's make this chart. We'll look at these 4. If you're given the formula, how to write the name. Make your chart a little neater than I'm making mine. Okay, when lithium and chlorine combine, they form something called lithium chloride. You're going to see a pattern here how I'm making this formula correct, and we're going to talk about that next. Okay, so the naming, let's write these 3 and then we'll give you the rules for naming. Calcium bromide, Br2, forms a solid. These are all ionic, they're all going to be solid. And iron 3, or just good old iron, the most common form of iron, iron nitride, Fen, solid again. Notice all ionic compounds are solid. Okay, so here's how to name an ionic compound. Basically 2 things. So element 1, you just say its name. That's it. You don't do anything. You don't say die. You don't say try. It doesn't matter if there's 27 of them. You just say its name. Element 1, name. Element 2, name-ide. You just add "ide" to the end. That's it. You don't have to say die, try, so it's different than molecular. It's just name, name-ide. So therefore, this is just lithium right off my periodic table. Chloride. Again, if it's ionic, and just add that in so it makes sense. You know, right here on the I, we add the ide. Calcium, therefore, on this one. Calcium bromide. Again, add that ide so it just kind of makes sense in the word. Iron, because Fe is iron, right? Iron just says its name. It's the first one. Nitride. There we go. That's how to name molecular compounds. Let's look how to write the formula. We're going to give an example where beryllium, find beryllium on your periodic table, and arsenic are going to combine. So the metal beryllium combines with arsenic. So these are two metal and non-metal. It's going to work. We want to get the formula. We're just going to do some rough work. Use the ion charge to get the formula. So just a little bit of rough work here. Essentially, I want to write beryllium's charge, +2 or 2+, doesn't matter which direction you write that in, and arsenic, As, -3. So these don't nicely balance off to 0. I wonder if I had 2 beryllium atoms, +2, +2, that'd be +4. That doesn't quite work. Let's do 2 of these here as well. So we got -6. Oh, I can see. This adds up to -6. -3, and you get another -3, -6. This is going to add up to +6, right? If we get 3 of these. The other way you can look at this is what's the lowest common multiple of these two numbers? The good old LCM, right? And so we list the multiples of 2, 2, 4, 6. You could list them for a whole while, but let's list the multiples of 3, 3, 6. There we go. There's the lowest common multiple. Therefore, you just need 3 berylliums, and you only need 2 arsenics. So that's going to be a proper, nicely balanced formula. Be3As2, you know the state of matter. This is an ionic compound because these are both conform ions, so they can link together. Solid. And that's it. Okay, so on page 45 in your textbook, chapter 2, you'll want to turn to that. The link again to the textbook is in the video description here. Just my computer's going a little slow. There we go, caught up. So these questions, practice questions, do them. The answers are in the Moodle site. We've got the answers to the textbook, so you can check those. And there's a few more practice problems here on page 46, so 45, 46. After that, go into Moodle and complete the ionic compound mini assignment. It's actually just 3 questions. Okay, that's it. Chemistry out. You have a good day. That's ionic compounds, what they are, how to name them, how to write the formula. Science 10 out.